right, welcome everybody. I'm going to go ahead and get started. My name is Matt Hardy. I'm the Program Director for Planning and Performance Management here at AASHTO. I want to welcome everybody to Webinar 24 in our Transportation Asset Management webinar series that has been sponsored by both FHWA and AASHTO over the past 4 years. The topic of today's webinar is lifecycle planning and transportation asset management plans. We have presented webinars in this series every 2 months, going back to 2012, on a variety of topics in asset management. For more information on this webinar series and for recordings and archives of all the previous webinars, you can visit our website, the TAM portal, at tam.transportation.org, or you can go to tam-portal.com. Both of them will take you to the same TAM portal with lots of other information besides the webinars. If you want specific information about the webinars, click on the TAM events in the main menu, and you can register for our future webinars. We hold these every other month at the same time, the second Wednesday of the month at 2 p.m. Eastern. You can also reach the site from FHWA's Asset Management Home. Their URL is fhwa.dot.gov/asset. If you have any suggestions on future webinar topics or have any questions for the presenters during today's webinar, please submit your comments or questions using the webinar's Q&A feature. And also, if you're going to be at TRB, the Transportation Research Board annual meeting in January, I would encourage you to stop by the AASHTO Transportation Asset Management Subcommittee meeting. It's going to be on Monday, January 9th from 10:15 until noon, chaired by Tim Hinkle from the Minnesota DOT. We're also going to be, one of our agenda topics is to figure out what webinar topics we want to sort of talk about in 2017. And I would also be remiss if I didn't say, sort of put a plug in for AASHTO's conference on performance-based transportation planning, finance, and management. This is happening July 31st through August 4th, 2017 in Cincinnati, Ohio. This is where the Standing Committee on Planning, the Standing Committee on Performance Management, the Subcommittee on Asset Management, and the Subcommittee on Transportation Finance Policy are going to be getting together and having their summer meeting. You can go to the AASHTO website, you can go to the TAM website, and get more information about the conference, as well as submit your ideas for what type of sessions should be taking place at the conference. At the end, as I said, at the end of this webinar, we will be doing the Q&A. So as you have questions, please type them, post them in the Q&A pod over there on the right hand on your toolbar within the GoToWebinar screen, so that we can take note of those and get them answered. With that, I'll turn it over to Max Grogg of FHWA for a brief introduction of today's topic. Max, all yours.
Thank you, Matt. Hello, everybody. As Matt mentioned, I'm Max Grogg with Federal Highways Office of Asset Management, Pavement, and Construction. Federal Highways, in cooperation with AASHTO Subcommittee on Asset Management, is very pleased to sponsor this webinar series. These webinars have been a great way to bring people together around a series of important topics and connect with the asset management community as we move forward on this in the country today. On the agenda today, we're going to hear 4 different perspectives on life cycle planning in relation to transportation asset management plans. It's a full agenda, so I'm not going to say too many things. If we could have the next slide. I do just want to mention a couple things. You know, a life cycle plan is a strategy for managing a group of assets with the aim of maintaining a specific level of service while minimizing costs. And so life cycle planning really provides a foundation for transportation asset management. It's informed by, but it's different than life cycle cost analysis, which many of you are probably familiar with, as states do that as pavement type selection or bridge type selection. So it's a different animal than that, but it is related. But most importantly, life cycle planning is supported by the management systems that you have, whether those are pavement management or bridge management systems. So FHWA's Office of Asset Management is working to help agencies understand how a strong approach to life cycle planning can be used to not only improve their asset management decision making, but most importantly, their outcomes. And we're helping encourage the use of the tools and resources that are available today for strengthening that. As you can see on the bottom of this slide is the URL for Federal Highways asset management website that Matt mentioned. And I would encourage you to visit this. There's a lot of different resources. And one of the things that I would encourage you in regard to today's webinar, there are transportation asset management plans from many different states there. I would draw your attention to the one from Minnesota DOT. They've done a really good job of some basic life cycle planning. And if you're starting the development of your TAMP, I'd advise you to take a simple approach to this and then add more details as your system matures. I'd also like to mention that FHWA is developing some frameworks for life cycle planning, financial plans, and risks, and these will be relatively short documents that'll be for your use as you're working on your asset management plans. And these should be available during the first half of 2017. So with that, I'm going to turn it over to Perry from SpyPond Partners, who will give you an overview of today's learning objectives, today's agenda, and introduce our speakers. So Perry.
Okay, thank you, Max. Now, as Max mentioned previously, the purpose of the webinar series is to share lessons learned, ideas, and knowledge with the asset management community. For this webinar, the primary learning objectives are to build working knowledge of key concepts and definitions relevant to life cycle planning, to strengthen understanding of specific applications of life cycle planning with respect to transportation asset management plans and programs, and then beginning to apply this knowledge in order to answer some simple questions. How can agencies apply life cycle planning in their asset management plans? What benefits can states expect by addressing life cycle planning in their TAMs plans and programs? And what are the key lessons learned for agencies seeking to strengthen life cycle planning capabilities as part of their TAM plans and programs? And then, of course, to share lessons learned, ideas, and knowledge. For the agenda today, we started off by hearing from Matt Hardy and Max Grog. I'll introduce our speakers before each presentation, but in brief, we'll start off with Carlos Braceras of the Utah Department of Transportation, who will provide an introduction to life cycle planning in asset management. Next, we'll hear from Anna Roback of Opus International Consulting. Next, we'll hear from Laura Zale of SEPTA. And for our final presentation, we'll have Bill Robert of SpyPond Partners, and then we'll wrap up with a Q&A at the end. So just another reminder, please submit your comments or questions using the chat webinar's Q&A feature or chat pod in the webinar menu bar anytime during today's presentations. And then in response to the most frequently asked question, we will make the slides and video available after today's webinar at tam-portal.com. For those of you connecting from your desktop, you can download the slides right now from the webinar's handouts control panel. Throughout the webinar today, the audience will be muted by default, so presenters should be sure to mute and unmute your line. And I think that covers the logistics for today's webinar. The only note for our presenters, I'll give you a warning when you have 2 minutes remaining in your allotted time if it looks like there's any danger of running over. Our first speaker today is Carlos Braceras of Utah DOT. Carlos is Executive Director of the Utah Department of Transportation, a position he has held for 3 years. A native of New Jersey, Carlos came to work at UDOT in 1986 because he loved skiing in Utah. And in the 30 years that have passed since then, he has helped to shape UDOT's strategic direction and its mission of innovating transportation solutions that strengthen Utah's economy and enhance the quality of life, making it one of the most respected and influential DOTs in the nation. Today, his influence extends beyond the state of Utah through his service on a number of national and regional boards and committees, including his current assignment as president of AASHTO, the Western Association of State Highway and Transportation Officials. And with that, I'll turn it over to Carlos.
Thank you, Perry, very much, and welcome to all of you that are participating today. I'm really honored to be able to spend a few minutes here with you, and I will not be providing you with any technical information to help you at all. I'm going to be speaking more from a business perspective on what asset management has meant to our organization and how it's helped us really address our mission as a DOT. As Perry mentioned, we have what we call our roadmap, and it's all about keeping Utah moving. And when we talk about our roadmap, we have our why, That's our mission. That's why we exist as an organization. That's why we do what we do. That's all about the economy and the quality of life. We have what we do. Those are our 3 strategic goals of 0 fatalities, 0 injuries, 0 crashes. We have preserving infrastructure, and we have optimizing mobility. And when we talk about asset management, I think we tend to focus primarily on the preserving infrastructure goal, more so than anything else, and it's the area that we've been focused on for probably now the last 15 years. And the one lesson that I would say that has helped us in our implementation is we made the goal right at the front that we were going to start simple, start small, and I think that has been a real key to help us make this move forward. Now, when we talk about asset management here, for us, it's really that discussion of, we're a lot of engineers, we're a lot of technicians, but for us, it's about running a business. And we're, as infrastructure owners and operators, we're all responsible for running a very large business and organization. And when we start using asset management, we now start communicating in a language that is more business-centric. And I know our elected officials, they kind of get it much more so than if we start talking engineerese to them. And so we work to try to, we use the word minimize life cycle costs. I've been using the term lowest cost of ownership for our assets, and being able to not pass on liabilities to future generations, and using that type of language as I communicate with the public and elected officials. Obviously, we're trying to maximize the performance, making our system for the investment levels we have, making it operate the best we can possibly do from an asset condition perspective, as well as from a transportation performance perspective. And we like to say that we're using data to help drive decisions. If we're using data to help inform decision making. As soon as you start giving people a thought that you've got a black box with a lot of complicated algorithms and a lot of data in there, and you can push a button, and now decision makers, the public, elected officials are no longer part of that decision process, I think it will hurt us. So we use data to help support the decision making process. And it's really important to be able to tie inputs in terms of funding levels, people, the equipment, materials, whatever that might be, being able to tie inputs to outcomes and why those outcomes actually matter to the public. So we need to be able to be translating our engineering level outcomes. If we're talking about overall condition index, well, what in the world does that really mean to the public, and why do they care about it? And we need to be able to do that, and that's really an important part, I believe, of asset management. If we can move to slide 2, we strongly believe that asset management has helped us extend the asset value and extend the life of our assets. Years ago, we realized we did not have enough funding in order to be able to treat all roads the same. So urban interstates, treating them to the same target levels, managing them the same as a very rural roadway. We realized that because asset management gave us that information. And so it helped us make better decisions for those roads, so that we were treating roads appropriate to the context that they were in. We've been working over time to be able to determine the value of our assets and have that all documented in what we refer to as an asset register. We're constantly gathering data, just like every other infrastructure owner. I mean, that's something we're really good at, is gathering data, but we're also been working a lot at organizing that data and being able to then develop the system so that we can now use that data to help make better decisions. And it's all about, doing the right project at the right time so that we get the best outcomes. And, we often get that question, why are you working on this good road over here when you've got this, crappy road over here? And through asset management, we're able to tell a very compelling business-based story that helps them understand, and it gives them a high level of trust that we're doing the right thing with their money. I think just like, if we go to the next slide, I think just like every other infrastructure owner and operator, if you were to look at your 2 highest value assets, it's going to be pavements and bridges. For us, Our pavements are about $24 billion. Our bridges are about $8 billion worth of asset value that we're responsible for managing across the state. Years ago, in fact, it's probably close to 30 years ago, we had a researcher here that started saying that we need to be talking about good roads cost less. And so that's something I've grown up with for over 30 years at UDOT, is this motto that good roads cost less, good bridges cost less. That idea of, you know, if you have a good road, you keep it in good condition, you can extend that asset value, that lower cost of ownership. And that's when people start to understand that. We have, you know, decided that we're going to manage our pavements at different target levels, which we feel is very appropriate, and asset management allows us to do that. Again, I believe being more responsible with the public's investment, the goal that they've given us to manage, and our bridges as well. We manage that through a lowest cost of ownership model as well. We've been collecting the performance measures on our assets, and I can't tell you how effectively that's allowed us to communicate with our legislature. And if you go to the last slide, it gets down to what I consider to be some of the two values that we try to manage, and it's the transparency and public trust. When we're able to put the work of the public out in a way that they can understand, we grow the public's trust. And asset management has allowed us to do that. And like I said earlier, tie those investments to outcomes. Don't call it money, call it investments, because you're getting something that's important for the public. And because we've been able to use this and we've been consistent, we've been able to show at this investment level, this is going to be the condition level for our pavements in these different classes of pavements that I talked about earlier. And because the legislature saw our pavement conditions on our low volume roads going down over time, projected to go down over time, and because they understood that good roads cost less, they did not want to pass on an unfunded liability to the children of Utah. And it was because of this that we got a gas tax increase in 2015 with no projects tied to it. The only thing that was tied to it was a histogram that showed that for this additional investment, this additional 5-cent gas tax increase, this is the projected condition improvement of those pavements, of those bridges with that investment. And each year we've been able to go back there and show that, yes, we're starting to track in the condition in the direction that we had committed to with that investment level. And that has led us to a place where I can say this and pass what I call the red face test. We have a financially sustainable transportation system in the state of Utah because of our use of asset management in a consistent basis for the last close to 15 years, but really effectively being able to use it and communicate with it for the last 5 years. And so with that, Perry, I think I've completed my spiel.
All right. Thank you, Carlos, for joining us today. Our next presentation, so we'll hear next from Anna Robach. Anna is the Global Director of Asset Management at Opus International Consultants. Anna was based in New Zealand for 13 years and returned to Canada earlier this year. After her civil engineering degree, Anna gained a master's in one of the first known asset management master's programs and later a PhD in economics, focusing on people's willingness to pay for improved infrastructure services. In her discussion, Anna will share philosophies and examples gathered from asset owners in the UK, New Zealand, Canada, Malaysia, Saudi Arabia, the UAE, and the US. And now I will turn this control over to Anna.
Hi, sorry, multitasking, trying to get my own screen up. Just a sec. Okay. Is everyone seeing, sorry, are you seeing the presentation view?
Yes.
Okay, great. So my perspective is that of an old Ministry of Works in New Zealand that privatized, and that was 20, 30 years ago. And as that happened, the idea, of course, was to become more efficient, to spend less money. And as that happened, indeed, the ministry and the country itself did become more efficient in its spending on its transportation system. But at some stage, things started to get a little bit disconnected, because as each piece became more efficient, some of those communications between departments and between parts of the planning disconnected from each other, to the point where the activities in the end were a little bit disconnected from the goals that the ministry, that the entire country had in the first place for their transportation services. We started taking for granted that we actually needed these assets in the first place. And so the perspective that I want to bring to you today is that importance of the very first part of the life cycle management, life cycle planning process. It's identifying the need in the first place, and then the planning that comes after. So I will touch on each little stage of the life cycle planning process, and I will pepper it with a few examples from around the world. And I also want to introduce some principles that I think are especially important as you're going through your life cycle planning process. I think especially because it's so easy to get caught up in the slippery slope of cost cutting, to the point where you've got, I've heard the term anorexic organization bandied around from time to time. So staying away from that, keeping that focus, as the previous speaker said, on what your goal is, what the outcomes are in the first place. So here is what I'm going to start with, is this life cycle management, or life cycle planning versus maintenance management. And I suspect you've all seen something very similar to this before. The whole idea is that it's actually about, having confidence that you can meet your agreed levels of service for the least cost. And I've also added something about risk in there in the long term. Now, you can't get least cost and least risk at the same time much of the time, but the idea is that you're balancing those. And I think an important question to ask when somebody says, hey, look, we're managing our transportation system really well. You know, we know that every 5 years we might do something to our pavements, and we're happy with that. We know it works. But what you don't know is, when you don't have that much budget anymore and you have to change your maintenance regime, do you actually know what it's going to cost in the long term, what your risks are going to be in the long term, and what that's going to do to your level of service in the long term? So for me, it all comes back to that confidence in those outcomes, the costs, and the risks. So I'm just going to start by sharing the parts of the asset life cycle. You could definitely argue with the steps in this life cycle. The point of that is not to say these are the definitive parts of it, but in general, I think everyone can agree that this is what's involved. You start at the top here by saying, look, we identify what our need is. What is that in the first place? We plan for it. We do some designs. We build what we need. We then operate it. We then might rehabilitate and modify. We might operate some more, and then we'll dispose. And then we come back to identifying the need again. So with that in mind, at each step of the way, consider what is your impact on the subsequent steps. And also, at each step of the way, is there something else I could have done earlier that would have reduced the problem that I'm in now, mitigated the problem that I'm having now? So I want to introduce some responsibilities that I think the life cycle management or life cycle planning process has. At each stage in that life cycle is to understand what are the requirements of your asset or group of assets in order to achieve those agreed levels of service. The next one is to understand the costs and the unintended positive and negative consequences of that decision. And the reason you want to do that is to consider if there are alternatives that might have a lesser impact or a more positive impact, but also, does whatever you're doing contribute to some other goals that are perhaps not your primary goals? The next responsibility is to look both upstream and downstream for areas of improvements. And when I say looking upstream, it means if you're in the design stage, maybe there was something that could have been, maybe there was a better plan in the first place. Maybe you didn't have to be designing what you're designing right now. To actually have a communication loop with the upstream to propose another way of planning for this life cycle. The next one is actually to negotiate changes in the entire life cycle management process. So now that I'm stuck designing this thing, can we perhaps do something different? Or maybe now that I'm planning for this thing, could we actually have funded something more? Was there another way of doing this? Was there someone else that could have benefited from what I think is a better solution? And then to go back and monitor and review your assumptions about costs, risks, and level of service achievement. I think the previous speaker also mentioned how they were able to show that they had actually achieved what they said they would achieve, or at least were heading in that direction. And that's something that seems to be lacking from an awful lot of plans. And finally, updating those plans according to your reality. So next time around, next time you're doing your plans, what really happens? Just to show that life cycle in a slightly different way, I want to show a timeline view. So this is just a stretched out view. And the reason I want to show this is to try to emphasize just how much your influence over the costs and the risks and your level of service can decrease throughout the life of your asset. Right up front, when you're identifying the need and planning something new, you have infinite possibilities for the directions the costs and the risks can go in. But once you've committed to a particular asset or a particular solution, then quite quickly, as you can see, you go from planning to design. Once you've already designed something, your opportunities for the costs and performance of whatever you're going to be creating are reducing at every stage. Just another way of showing that. And I've grabbed some examples, I should have said earlier, not only from international, but also from different kinds of asset groups, from different industries altogether. So this is from the process industry. And this diagram is showing that over time, from the very beginning of your asset, whatever asset that might be, at the beginning of the life cycle, your costs for mitigating risks are extremely low, if you see that red line down there. But over time, your cost to mitigate any risks increase dramatically. At the same time, what I was discussing in the previous slide, with the dotted black line, you can see that your opportunities for creating savings are very high at the very beginning, but they quickly drop off as well. So this is just another way to try to emphasize the importance of thinking right up front, what is it we actually need? And here's another one I found as well, again from the industrial side, how at each phase you've committed so much cost, and you can see how quickly you've committed cost into the long term of whatever asset you've chosen. So if I go back to the original asset life cycle, I want to focus on the first two parts, identifying that need for the asset in the first place, and then planning for it. So if I take the overall, it's kind of an iterative process here. The first thing you do is set some goals. You decide what those assets are going to be that will help you achieve those goals and how they have to perform in order to do that. You figure out what the costs are now and in the future. You figure out how to minimize those costs, so optimizing. And then here's the question. You always ask, can we afford it? But here's the part that doesn't tend to happen so often, is the part where you actually review those performance goals, or you manage your demand. What tends to happen most often is that we prioritize what we invest in. But what I found, in a lot of examples from around the world, in that prioritization process, there is rarely a review of what those performance goals were, rarely a management of demand. So what tends to happen is that people are sort of pseudo still saying, these are performance goals, even though they know that there's no way of meeting them. So this iterative process of going back, now we know we can't afford it with our existing finances, what can we do with it? Well, here's three options. Another option is actually to go and figure out if we can get more funding for this. And I think there are actually a lot of ways of doing that, a lot of creative ways that are being done. So I want to share a few examples of that very first part of the asset lifecycle, which is identifying the need for an asset in the first place. This is an example mostly from the water utility side of things. In each of these cases, and I'll focus on, many of you might have heard of the New York City example, where a new drinking water treatment plant was needed. Or that's what they thought was needed. That's what they had taken for granted because that was what they'd always used in the past. But instead, the utility negotiated and worked with landowners upstream and figured out a way that they wouldn't actually have to upgrade these water treatment plants. So using watershed conservation, instead of building these new water treatment plants, they saved themselves at least $6.5 billion, which is pretty substantial. So you can see what I've done at the top there with this little unattractive star is shown that here we've got the solution, the identifying need at the very top when we have the greatest impact, the greatest ability to influence. And that's what they managed to do here, which meant that over the entire remaining life cycle, they had much more control. They were able to reduce the cost dramatically, the risks dramatically, and also the performance. I've got another example as well, which is a bit probably closer to home. And this just came out recently. New Jersey town decides to pay Uber instead of building a parking lot. So this is another great example of an upfront, non-asset solution where Uber is coming in with that whole concept of the last mile. And instead of building a car park, using a private provider, Uber, to provide the same solution to them. And just one more example of how identifying the need, just an alternative way of doing this. The Harbor Bridge in Auckland was going to need, basically the idea was that they had a consent that told them they had to stop dropping zinc into the harbor, which is a pretty fair requirement. So they found that the traditional way of doing that would have meant that they had to put some kind of a cage onto the bridge. Now this cage, to put it onto the bridge, would have meant they would have had to strengthen the bridge substantially. That would have cost them $65 million just to build this structure in the first place, let alone the longer-term costs of maintenance. So they did some research on different ways of painting the bridge so that the zinc that they were dropping every time they had to scrape and repaint, they could minimize that to very little. So they were spot spraying is what they were doing instead. And it's very, when you say it, it's a very simple solution, but it's one of them that wasn't obvious because of the way the consent conditions were described. So going back to the asset life cycle, I'm going to go all the way to the end because I think this is the other part that we can focus on a bit more. It's the disposal part. And it is so well linked to identifying the need in the first place. Because, I'll go through this very quickly, your service quality changes very quickly over time. You could argue that at some stage along the change of your service quality, you no longer meet your service requirements. That you could call your end of your life. But you've also got these many, many other ways in which you could reach the end of your service life. And having all of those in mind is very important. Because what we tend to do is look at just the age or just one or two aspects of condition. We don't tend to overlay also the capacity, the availability, and other important goals that we have. Another way of looking at it, and I'm just going to overlay the risk side of it here, is to say that at some stage, we no longer meet our risk requirements. So you can see how the condition is deteriorating over time, and at some stage it becomes unacceptable. And the unacceptable level may be different for condition to what it is for capacity. But regardless of what criteria you're using, the end of your life can be reached at many, many different stages. And it's important not just to focus on condition. So you can see the list here: structural strength, capacity versus demand, the amenity, comfort, appearance. the function, the physical failure, technological changes, the cost to operate and maintain, the risk is higher than what we're willing to accept. So any of these conditions can create the end of your life. And when you're doing that life cycle planning, is to be aware of all of those possible end of life conditions. So just to go one back, here's where we often focus on the operating, maintaining, monitoring, rehabilitating. This, I'm actually going to skip through this fairly quickly because I think this is all pretty basic for you. You've got, your construction cost, and over time, at some stage, when your performance crosses over your no longer meeting service level requirement line, you're replaced with something else, and there's your replacement cost. Likewise, your performance, when you intervene, can be extended to a little bit later. So it's being aware of how much that your performance can be extended based on your construction costs in the first place or different forms of rehabilitation. And again, probably a very ubiquitous kind of chart for you, but over time you replace more frequently or you wait a little bit longer and you replace later. But I do want to add here that it's not just about the life cycle costs that you expect to happen. You can also consider the risks of something going wrong that you didn't necessarily expect to have happen. And I'll give you an example of that. Here, it was the Auckland Council, and it was their stormwater team that was looking at their stormwater treatment devices. And they found that if they changed the maintenance regime from 3 times a year to twice a year, and this was literally just an inspection regime, it affected their longer-term agency costs, their costs to road users, and their risks to staff to road users in a very minimal way. So the cost itself of reducing from 3 to 2 inspections per year, it obviously reduced the cost by about 1/3, but the cost to road users were significantly reduced because they didn't have to close the shoulders or roads. It also reduced the risk to staff and to road users, again, because they weren't out there that extra time doing that work. I'm just going to skip through because I think we're just about there with our time.
Yep, this is just about the 2-minute warning.
Okay, so through each stage, these will be in your available to you anyway. But I just wanted to say with each stage what you can consider in the life cycle. And most importantly, specifying what your outcomes are, as opposed to the solution, not assuming that you're going to need that same asset in your replacement later on. And also considering that each asset or each solution can be contributing to multiple outcomes. In the planning stage in particular, consider a lot more about managing demand, negotiating, and when I say negotiating, it's negotiating who might pay for this solution. It could be your road users, it could be other agencies that also benefit from what you're doing, or agencies that are putting costs onto you. Maybe even just other departments that you're not connected all that well to. And then there's other non-asset solutions too, thinking even more creatively. Design and maintenance, it's a similar kind of thing. Considering how your design specifications and your maintenance specifications are affecting what happens downstream. Could you actually consider a lower design standard? Would you still be within your risk requirements? And so I'm just going to flick through these guys because they're all quite similar until the disposal part, where, as I showed you a little bit earlier, there are all kinds of different end-of-life conditions that you could be considering. And then when you come back to planning for your next assets, considering replacing them with non-asset solutions, and what you'll do in the interim when you're transitioning from one to the other. So the principles of lifecycle planning and management are to show how those lifecycle decisions affect your agreed levels of service, and your portfolio level risks and costs. To challenge, monitor, and review those assumptions at each stage of that life cycle to really look forward and look back, looking upstream and downstream. Considering those new ways of achieving your level of service, especially considering all the technology we have now and all the research we have about understanding how people behave differently depending on what they see on the road. And then updating your policies, practices, and procedures with things that you've discovered and learned. Too much of this, we do some great work, and it doesn't update itself. It doesn't get updated in the next iteration. And that was really all I wanted to share with you. I think for me, such an importance on thinking of what that need is in the first place and considering very different kinds of solutions to what we've done in the past. Thank you.
All right, thanks, Anna. Okay, so our next presentation is from Laura Zale with the Southeastern Pennsylvania Transportation Authority, or SEPTA. Laura has worked at SEPTA for 8 years, and she is a program lead for the authority's Transit Asset Management Program. She also coordinates SEPTA's construction on Amtrak's Northeast Corridor and performs public relation duties for our SEPTA's Rebuilding for the Future program. Laura holds undergraduate degrees in civil and architectural engineering from Drexel University. And now I'll turn it over to Laura.
Thank you, Perry. Good afternoon from Philadelphia, where it's a bit cold today, but as always, sunny. I am here to talk about the program that we are implementing at SEPTA. We are in the process of implementing a TAM program. So you'll hear me talk about some of the things that we have going on, but you'll also hear me say that we're not quite there yet, either in the development of our final plan as well as our data collection processes. But one of the things I do want to say is that I was really struck earlier this afternoon when Carlos was speaking, because while Carlos and I are responsible for maintaining very different asset portfolios, I have one road and he has many, etc. We really share a similar philosophy about asset management, and I think that those sorts of things can be helpful to other folks that might either be starting out or really trying to branch out their use of the practice of asset management. One of those, I would say, is to start simple, keep it simple, and then start to expand. And the other is this idea that data has to speak to multiple audiences. So Carlos spoke about that a little bit, and I'm going to touch on it in my presentation as well. And just to give you a little bit of background of what we're dealing with at SEPTA, we are a quote-unquote legacy transportation system. We were created between 1964 and 1983 by the state of Pennsylvania to consolidate a lot of what unfortunately had become bankrupt transportation providers in the state of Pennsylvania. We had the Reading Railroad, the Pennsylvania Railroad, the P&W, for all you rail buffs out there. A lot of these assets had fallen into a state of disrepair before SEPTA assumed their operation. Maintenance and record keeping were definitely not practices of these about to go bankrupt businesses, and this really became apparent when we took over the railroad in 1983. The result of that consolidation is that we are an expansive and truly multimodal transit system. We're the 6th largest in the country. We operate over 2,200 square miles, over 7 counties and 3 states. We operate heavy rail, commuter rail, light rail, bus. We have trackless trolley, interurban rail, and a paratransit or demand response service. And one of the things that makes asset management even more fun is that we utilize infrastructure that isn't necessarily maintained by us. We share assets with Amtrak, with the freight railroads, with the city of Philadelphia, to name a few. So we do, with all that consolidation, have a truly diverse asset portfolio. We maintain a fleet of about 4,000 vehicles, revenue and non-revenue. Even within the bus fleet, we have diesel, hybrid, as well as we're in the process of procuring electric buses. We also, on the rail fleet, have locomotives and 2 different generations of regional rail car. And all of those vehicles operate on a also very diverse asset portfolio. We maintain 400 miles of mainline tracks, 364 bridges, etc. These assets themselves are maintained generally by 4 divisions of engineers, our bridges and buildings, electric traction, track, and then communications and signals. So asset management not only is a challenge because of the diversity of our portfolio, but also because of the diversity of the folks that are maintaining these assets. Our asset management program, while we were doing a lot of asset management type principles before, really came into focus a couple of years ago when we found ourselves in a situation where we had to articulate the need for additional state funding, and we did a very comprehensive state of good repair needs analysis where we were able to demonstrate to our legislators, to the folks of Pennsylvania, that yes, we had this $5 billion backlog. Compare that to what the FTA estimates is about an $89 billion backlog. However, we found that people really don't relate to numbers that are that big, so we took it a step further and said, okay, if we can't maintain certain lines in a state of good repair, if we allow conditions to deteriorate, this is what will happen to the system over a 10-year period. And we were able to use that to articulate our need for state funding, and also that we were going to be good custodians of any funding that we received. We were able to use this data to tell a very successful story. The state of Pennsylvania passed the new transportation funding bill in November of 2013. This is the first time in quite a while that SEPTA's had a sustainable funding source. It's for the entire state of Pennsylvania and for transportation, not just transit, but we were very happy that transit was included. And as we continue to go forward and develop our corporate plans, we always reiterate that rebuilding our system is always a strategic business goal. It's had a few different names, but rebuilding, maintaining our existing assets is very core to SEPTA's mission. To give you a little background of our asset management program, we started by initially developing the framework. What do we want to accomplish with this? It's not just a matter of compliance. How are we going to use data to better make decisions? We developed a framework and we identified and studied the existing practices. We conducted a gap analysis. And based on those needs that we identified, we procured some software tools. We developed our capital needs inventory, which is a little different than our daily asset inventory. We're in the process of implementing our maintenance management systems, and we're in the process of developing our final asset management plan. Some of this we've waited a little bit to have the final NAT 21 recommendations from the FTA. They came out in July, and now we're just making sure everything that we're doing is in alignment with the plans that were given by the FTA. I want to touch on this idea that we are using software. It's a very powerful tool. It's a program enabler. We are relying on software to maintain our inventories for vehicles as well as maintenance. We have a decision-making tool that helps us prioritize investments, and that was where we keep our capital asset inventory that we use to report to FTA and or the state of Pennsylvania. But all the way that this is governed is being documented through our asset management plan. I stress this to make sure that if you haven't really developed your program yet, if you're worried about buying software, I strongly suggest that you get all this process mapped out before you start shopping, because none of these things work correctly for you straight out of the box, and really get an idea of what your process is before you start working on a software implementation. So let's talk about these systems. We talk about how we're collecting a lot of data. What are we doing with it? We'll talk a little bit about how we deal with it on the rolling stock side of the house. We've had the maintenance management system in there since the early 90s, and we use a lot of that data very heavily to drive not only our daily operations, but also to develop what our overhaul program is. Depending on the vehicle, we do a midlife overhaul. On the rail side of the house, we do overhauls every 4 to 6 years on each of the fleet throughout their useful life. And we use the data from the maintenance management system to develop what will be the VOH program and to also figure out what we want to do with the vehicles when we replace them. On the infrastructure side of the house, it's a very delicate balance, and I'm showing you this plan to show how we look at our infrastructure plan over a 5-year horizon. And we do have certain components of the rail infrastructure, particularly the drive, when we do maintenance in certain sections of the railroad or on the trolley. It's either based on the life of the ties or the life of the overhead wire. But then what we do is if we have to go to the operations folks and ask for some time, some outages on the track, we really try to get in there and do as much work as we can at the same time so we don't have to keep disrupting the passengers. So it's this delicate balance between the life cycle of the asset and minimizing impact to customers, with, of course, safety being a huge driver as well. We have some other things that tend to drive things on, particularly the railroad. The positive train control implementation. We're in the process of rationalizing our plant, and also the normal replacement of assets. As you can imagine, when you put together 2 different legacy railroad systems to combine them into one system, you have a lot of redundant infrastructure. We have a lot of interlockings that aren't in the optimal placement for where we want to have things today. And now that we have reliable sources of funding, we can really think about how we want to improve the system for today's riders. And talk a little bit more, we do a lot of these corridor type approaches in the summer. There are times when we have to shut down a line to do what we call a bus bridge. We tend to do those in the summer because in the summer we gain about 100 vehicles back into the fleet because we're not running the school trips. We go through an extensive planning process to develop where the work crews will be. And this not only it helps us 2 ways. One is that we get better project data right out of the field when we are replacing the assets. We know who is doing what and where and what is getting changed or reconfigured on a day-to-day basis. But more importantly, it really leads to a safer work environment. We did a project last summer on our trolley lines where we had 17 work crews working over a 5-mile section of trolley track through a 12-week outage, and we had 2 injuries, and we actually finished several of the projects ahead of schedule. So not only the schedule gain is great, but really maintaining the safety of the work environment was a big win for us there. We talk about data, we talk about having a backlog. We also use the data in order to figure out when do you prioritize doing some of these things. You know, all of them are old. On the right-hand side of the screen, I'm showing a picture of one of our vintage 1930 traction power substations. The adjective that we used to describe these substations was Frankenstein-esque. We have 18 of these throughout the system, and we really wanted to develop a program to minimize impact to the riders as well as address any identified risks. So we go through that sort of exercise with the data that we collect to develop what is now called our super substation program. Talked about risk in another way. One place where we're dealing with risk a lot is climate vulnerability. One of these things that we dealt with when we started to look at what do we do and when do we do it is this idea of legacy knowledge about what happens on the system when you have an extreme weather event. So we look at a lot of the information in our maintenance management system and develop future projects and assess what the impact to those projects would be on our system. And those are things that we have weighed and either asked for funding for and are starting to work on, or we've identified as future projects to be included in our capital needs program. There's a lot of ways to use this data to not only drive what you're doing in-house, but also to speak to people about why you want to do things in a certain order. Moving forward at SEPTA, we are finalizing our implementation of our enterprise maintenance management systems. We've pretty much aligned our framework with what is in place for MEP 21, and we are getting ready to put in our performance metrics for our system. We're finalizing our asset management plan. And then what we're doing is developing a PMP to gather asset data from the capital side of the house so that we can integrate those design principles into the systems right away, so we can start collecting data on them right away. And we continue to coordinate with agency stakeholders within the agency as well as externally. And that's what we're up to at SEPTA with asset management.
Thank you, Laura. Our final presentation today is from my colleague Bill Robert with Spy Pond Partners. I'm just going to grab control of the screen here. Let's see the slides. Bill is Vice President at SPP, has more than 20 years of experience in the transportation industry, and at SPP he focuses on implementing management systems and approaches to strengthen agencies' asset performance. He has designed and developed management and analysis systems, developed models for predicting conditions, performance, and costs, conducted economic analyses of investments, developed management frameworks, and assisted in defining the most economic management strategies. Bill is currently assisting in developing statewide asset management plans for the DOTs of Connecticut, Maryland, New Mexico, and Rhode Island. And now I'll turn it over to Bill.
Thanks, Perry. So I'm going to talk about lifecycle planning in transportation asset management. And the presentation is based on some materials that we've developed on an ongoing NCHRP project, Project 1912. The NCHRP project is led by Scott Richrath. It's on financial plan guidance. So this particular topic is something that we're addressing in terms of how lifecycle planning relates to financial plans. But I'm just going to present on the lifecycle planning aspect of the research. And a lot of the materials I'll be presenting are actually drawn from AASHTO, the TAM guide, volume 2. And I think it's probably interesting to contrast this presentation, which focuses on transportation and some of the U.S. guidance, with the materials Anna presented earlier that are international and cover a wider set of different assets. I think a lot of the basic concepts are similar, but I think what you'll see is a slightly different perspective. So next slide, please, Perry. So the basic concepts behind lifecycle planning are pretty well covered already by some of our previous presenters. This slide just shows an example of lifecycle costs over time for 2 different scenarios. So in the top panel, you see costs accruing on the bottom part of the graph, and conditions declining and improving over time. And this is meant to follow an asset management approach where interventions are timed over the course of the asset, and overall the asset stays in good condition. The bottom panel is one in which work is not being performed on an asset and condition declines, and then reconstruction or rehab work is performed less often, and ultimately resulting in worse condition and higher costs. So with lifecycle planning, trying to develop a strategy on how to manage an asset over its life cycle to get the best results. This particular example is actually reproduced from a publication that RIDOT put out, Rhode Island DOT, and it's based on some numbers that Texas DOT put as an example analysis on its website. Next slide, please. Now, I think one thing that's important to clarify is just what do we mean by lifecycle planning relative to lifecycle cost analysis. And lifecycle cost analysis is a well-established thing. There's a lot of great resources out there already. FHWA has its lifecycle cost analysis primer, as well as a bulletin on how to use lifecycle cost and pavement design. That's still kind of the authoritative document for lifecycle costing for pavement. And also FHWA has the system real cost for lifecycle costing for pavement. On the bridge side, there's not as much out there, but the authoritative report is in CHRP report 483 on bridge lifecycle costs. Hugh Hawk wrote. It's a great report to read on this topic. And the National Institute of Standards and Technology has a bridge lifecycle cost analysis tool for use in bridge design. It's also a good resource. So there's a lot of stuff out there already for lifecycle costs. Lifecycle planning is based on all the same ideas, but in lifecycle planning, the way the term has been applied by FHWA, we're addressing the programmatic application of lifecycle concepts, and we're looking at the overall strategy of how to maintain an asset over its life cycle rather than project-specific analysis. And really what this boils down to is that in life cycle planning, you have to address decision support using less detailed data than you would typically have for a life cycle cost analysis. Next slide, please. So this figure shows typical asset life cycle. This is similar to what Anna presented previously, except this is the version from the AASHTO TAM Guide Volume 2, showing the major phases of an asset. First is built or created, then maintained, renewed hopefully, and then ultimately disposed of. And so planning is intended to support really all of these steps from initial creation to maintain to renew. Okay, next slide. So this step lists the main processes that are encompassed by lifecycle planning, and so I'll talk about each of these briefly, and then we'll go into a little bit more detail on some things. First step in developing a lifecycle plan is to figure out what asset classes and subgroups one is concerned with. So, concerned with pavements, bridges, and then in some cases you may need to divide those further by element or by groups of types of asset. The next step is to figure out how the asset is going to behave over time or deteriorate over time, and what you can do about it. So what kinds of work can be performed? Can you do maintenance work? Can you what sort of rehab work or reconstruction work can you do? And then for each possible treatment that you might perform on an asset, how much will that treatment cost, and what will its effects be on asset condition? And usually in management systems or analyses, there's additional business rules and constraints. So for instance, you might be able to overlay pavement or bridge, but only so many times, or only at a certain threshold level. Or there might be constraints on how much of a certain kind of work you can do. So in a management system, these business rules and constraints are actually super important in developing a plan for what you're going to do over time. So with the business rules and constraints, the information on treatments, and a model of how assets deteriorate, you then can develop a life cycle strategy for each asset class or subgroup. And as part of that, also to figure out how you're going to prioritize actions if you don't have enough money to follow the strategy. So usually the strategy is going to deliver the best results at minimum cost or within a certain range of costs, but if you don't have that money, then you have to prioritize. And then finally, implement the life cycle plan through some sort of analytical approach. And by this, for pavements and bridges at least, we're usually talking about management systems, a pavement or bridge management system. Okay, next slide. So I'll say a little bit more about management systems. The existing management systems for pavements and bridges and other assets really are designed typically to support this whole set of steps that was listed in the last slide. Now, when we say management system, sometimes we mean a single monolithic IT system, but in a lot of cases, this really means a set of information systems and business processes. So, for instance, if you have a pavement management system, well, really, in a lot of states, you might have one system for data collection and data management, and then a separate analysis system that uses some curated version of that data. And then that management system may have a decision tree or something, but it may require some supplementary analysis on the side to figure out what the inputs and rules are to put into that system. So there you have a management system that's really multiple IT systems and additional business processes. Now, the FHWA asset management rule requires use of management systems broadly defined for NHS pavements and bridges. And a good reference for what a management system should have is really the AASHTO TAM guide. Next slide. And next couple of graphs are reproduced from the AASHTO guide. So this really important part of the process is to figure out what treatments you can perform. So what this slide shows are kind of steps in figuring out what treatments are feasible. So first you have to identify failure modes, which could be a range of different things, poor condition or lack of capacity or obsolescence. Then for each possible failure mode, figure out what you can do about it and what the costs are, define the treatment options, and then identify the best treatment option. So it all sounds good. You can just draw a figure illustrating those steps, but a lot of the magic in these systems is how to do that systematically. Next slide, please. And this is an example of a resulting life cycle strategy. So this particular example is a decision tree. This one is from a state DOT's bridge management system saying when to replace a bridge, replace superstructure, overlay a deck, or replace a deck depending on rating values for deck, superstructure, and substructure. Now, obviously, in a life cycle plan that you use to figure out sort of overall costs, overall conditions, this kind of thing is very useful. Once you get down to making specific project level decisions, you're going to consider a lot more data. So I think it's understood in a management system, you're looking at kind of an idealized analysis, not at trying to automate your project level decisions. Okay, next slide. So this next slide shows another version of a life cycle strategy. In this case, instead of using a decision tree, what we have is a bridge element policy. This particular example is taken from the unbiased National Bridge Investment Analysis system, which is similar in how it approaches things to the AASHTO BRM. But what we see are different condition states that an element may, an individual bridge structural element may exist in, what actions or work types have been defined for each condition state. So when the element is in a condition of 1, good, there's nothing that's defined. If it's in severe condition of 4, then you can do nothing, which is not recommended, rehabilitate or replace the element. Also in the graph we have a unit cost, and we say whether or not this is the treatment that's recommended in the life cycle strategy and what the benefit of that is. In this particular example, the benefit is the dollar saved by performing the action when you can, as opposed to deferring action for a year. But different systems use different approaches to calculating benefits and prioritizing. Okay, next slide. Now this one is a little hard to read, but we'll zoom in the next slide. But this is an example of how you might communicate your life cycle strategy in an asset management plan. Obviously, decision trees and tables of life cycle policies will push buttons for people like me, but for the most lay people, that's a little bit too much. It's a little hard for people to comprehend. So this is a visual from a document by Rhode Island DOT that shows that that DOT's strategy for maintaining pavements. So it talks about different treatment options, shows a nice photograph that explains how much each action costs and what it does and when the DOT performs it. And if you could go to the next slide that zooms in on this figure a little bit more. So in this particular inset view, we've got the details reproduced for reconstruction, mill and overlay, and crack sealing. So I would argue even when you have a very complex decision tree or very complex policy, you should be able to provide a narrative version of that boils it down to the basics for somebody can readily understand. And this is a great example of that. Next slide. So finally, I'd like to talk, we've covered the basic steps in lifecycle planning, and I think Anna did a great job of covering them even further in her presentation. The last few slides I'd like to talk about is how does lifecycle planning fit into the development of a TAMP, a Transportation Asset Management Plan, and also how does it fit into an overall Transportation Asset Management Program. So this figure shows is just sort of a version of the steps that an agency needs to perform to develop an FHWA compliant asset management plan. And in this particular figure, instead of using the term life cycle plan, we use life cycle strategies. But as you can see, it's the purple box, and it's right smack in the middle of the diagram. If you go to the next slide, then we break that out into different steps, and these are basically the same steps we talked about earlier. Define your asset classes and subgroups, develop the models, define the treatments, and so forth. Okay, next slide. So that's the figure. So how does lifecycle planning support development of your TAMP? Well, as I said, it's central. And also, there were some arrows between the different processes going back and forth. What this means is that you really have to develop your lifecycle plans in an interactive way. What FHWA specifies in the asset management rules, the lifecycle plan needs to needs to be set considering your condition targets. For instance, what might be the minimum acceptable condition you need to maintain. And so those need to be incorporated in the policy. And also, you need to you need to really think about whether the policy that you've specified, if you follow it, will actually achieve your agency targets. And if it won't, it's probably good to rethink those targets or rethink the policy. And once the policy is established, or once the life cycle planning is done, this gives the means to do a lot of the other things that are needed for an asset management plan, including predicting conditions, recommending preservation actions, and prioritizing. Okay, next slide. So finally, I'd like to talk about life cycle planning as a part of an overall TAM program. This figure it's basically a simplified version of the Institute for Asset Management, IAM, Asset Management Anatomy, showing 6 key areas where one needs to focus into as part of an overall asset management plan: organization of people, strategy and planning, resource allocation, life cycle management and monitoring, as well as information systems. So as you can see here, life cycle, well, maybe hard to see, so we've added a little circle. Life cycle planning is part of a set of processes all in life cycle management, and it relates directly to overall strategy and planning as well as monitoring. Next slide. So then, without going into the details of the figure, just how does life cycle planning relate to the overall TAM program? Well, I would say that the life cycle plan, first and foremost, is the meat, puts the meat on the bone for asset management. The whole premise of asset management gives you a way to manage your assets over their life cycle at least practical cost. The life cycle plan is where you define what the heck that means. So it's extremely important and is the backbone for an asset management approach. It's definitely a key activity in the life cycle management area that we've presented here. And you really need that life cycle plan, whether it's explicit or implicit. You need it spelled out in some fashion to develop an overall strategy, an overall plan. And it's not intended to be kind of a monolithic thing. The idea in any of these, process guidance is that you develop it, and as you get more information on condition, you iterate and improve the plan over time. And I think that's the last slide. At this point, I'll turn it back over to Perry.
Thank you, Bill. All right, that concludes our presentations for today. So thank you to all of our presenters. And now it's time for the Q&A. If you have a question, please type it into the Q&A tab of the webinar toolbar, and I will just we'll just take them in order as you type them. Okay, so our first question is for Laura. People would like to know the specific tools SEPTA is using for life cycle and maintenance management.
Okay, on the vehicle side of the house, we are using AssetWorks M5 for the fleet, and on the infrastructure side of the house, we are using AssetWorks FA Suite for our maintenance management systems.
Excellent. Thank you, Laura. And the next question is for Anna. How would you quantify or count the non-agency costs, such as user, non-user costs, and societal costs? And that this question comes from Imad Al-Thawi. And Anna, if you are speaking, it's possible you're on mute. And still no audio from Anna at the moment, although I see you're connected here. Okay, while we wait for Anna, Bill, looks like you could give an update on next steps for the 1912 project.
Sure. So the principal investigator for that project is Scott Richrath, and we're in the process of finalizing the first phase of that research, which is to develop draft guidance. The second phase is to go out and work with, we're in the process of finalizing that part. Second phase is to go out and work with individual DOTs to test the guidance. So I think if you're involved in the panel, there's a lot to see and do. If you're an innocent bystander waiting for the report to get published, I think it is probably at least a year out, given that we need to finish phase 2 and go through the TRB publications process before there's anything to see.
Okay, thank you. And it appears that we've lost Anna off the webinar, and she's trying to join back in. So the next question is open-ended, and Bill, I'm going to start with you. Is life cycle planning basically planning based on management system, or based on a management system?
You said it's based on a management system, Perry?
So yes. So the question is life cycle planning basically planning based on a management system?
Oh yeah, that's a great question. I would say that it's life cycle planning is basically spelling out the idealized way that you would maintain an asset over time. And usually it's one step in kind of running your management system. However, if Anna gets back in the line, I think she can speak more to this. I think that a management system only considers certain kinds of things. Even if you've got a really good management system, you may need to do additional analysis to bolster the decision rules and so forth that you put into it. Also, as Anna talked about, there's a lot of practical considerations that one would ideally address that go way beyond what a management system would do. So I think, to first order, it's an aspect of what a management system does, but there is a bit more to it when you kind of peel the onion back a bit.
Thanks, Bill. Now, Max, if we've got you on the line, would you like to elaborate at all?
Sure. I mean, I think Bill gave a pretty good answer there. I think the thing I'd kind of add to that is it's a little bit of a chicken and egg thing. It's not just planning based on your management systems. It really also provides a lot of feedback into it, and that was, I think, kind of the point Bill was making. So it's not just something that you go buy a piece of software and install it and run it, and then all of a sudden you get the life cycle planning type of thing. So it's really kind of sitting down and looking at a lot of the strategies, looking at the funding level you have, and looking at the targets as you develop your life cycle plans.
Thanks, Max. And Laura, if you'd like to jump in as well, you're welcome to. And if not, we can see if we've got Anna back on the line. Not yet, although you've reappeared here.
Oh, hey, sorry, I am back. Yeah, I just had to unmute myself.
Ah, fantastic. Okay, so the question that we had for you initially was, how would you quantify or account for non-agency costs, such as user and non-user costs and societal costs?
So some of I guess I'll break it down into 3 parts. One is, for whatever it is that you're wanting to find those costs for, what is it that people will do as a result of that decision or whatever happened? So for example, you need to repair the road, so people might either slow down, their travel time might slow down, they might take an alternative route. In those kinds of cases, it's fairly straightforward. You can just look at their time and their value of time and the vehicle operating costs. But there's also, if people do nothing differently as a result, how are they actually going to be affected? So it could be, for example, that maybe they keep doing what they were doing, but it causes them some stress. And maybe that stress means, and this is a much harder kind of thing to evaluate, but maybe that stress means that they need to take some time off work in the end, or maybe it means they have to go to the hospital for treatment. Those kinds of things, while it sounds really difficult, it's actually not that hard to get that kind of information from people if you do a little bit of survey work. But I won't go more into that. That's just the kind of general concept. And then what will be the concepts? The third part is, what will be the cost to the economy based on how people are affected? So if they have to go to the hospital, it's not just a cost to them. If you have healthcare, it could be a cost to the wider economy in that sense as well. And of course, you've got the environmental costs as well, what happens in terms of air pollution. And there are actually dollar values. I'm pretty sure the US has its own accepted dollar values as well for air pollution. So those kinds of things are actually not that hard to find. It's just a matter of consolidating them.
Thanks, Anna. So our next question, what is the general, short-term and long-term guideline for selecting the length of an analysis period, and how significant is the present worth, cost, or benefit of an asset at future times beyond a forecasted period? If you track that, Max, I can start with you on this one. If you'd like me to read it again, just let me know.
Yeah, why don't you read that one again to me?
Yeah.
I got part of it, but I didn't get the whole thing.
Yeah. What is the general, both short-term and long-term guideline for selecting the length of an analysis period? So that's part one. And how significant is the present worth, cost, or benefit of an asset at future times beyond the forecasted period?
So the analysis period is, basically the guidelines that Federal Highways used in the past is you wanted to at least go to the first major, rehab or reconstruction of your asset. So, so if you're, obviously that's going to be different whether you're talking about a pavement or a bridge. For a bridge, you might be talking 75 or 100 years or something like that. So that gets out there pretty far or whatever. Generally for pavements, most people have been looking, at 35 and 50-year analysis periods to try to get out there where the life, so to speak, has been, or a major portion of the life has been consumed. And so then, can you repeat the last part of the question again? That had to do, I think it was present worth. Was that the question?
Yeah. How significant is the present worth, or the benefit of an asset outside of the analysis, beyond a forecasted period?
And again, that's going to depend, on the asset and the type of life that you're talking about. But it's a good point that the questioner is making there, that when you start talking about costs that are out 50 or 75 years, and you start talking about discounting those back to present days, or when you're starting to look at even benefits, if you're trying to do that part of your analysis as well. So it's a consideration that needs to be looked at, and generally some of the guidance too is to try to look at some sensitivity analysis as you're doing those future costs and see what kind of effect different discount rates have. So there is the effect that's there, but it's somewhat dependent on the discount rate and how you're treating those.
Perry, could I add to this?
Please.
I would not. I'd never presumed to know more about guidance of what management systems do on this topic. Typically, you've got really two aspects of a management system analysis. One is developing the basic policy or decision tree.
Bill, I think that the line has cut out for a second there.
Oh, okay. Sorry. First, usually the initial development of lifecycle policy is independent of the specific analysis period, and in particular for things like bridges, a bridge is often monitored as a going concern, and then this question of how far out do you look usually comes into play as a second step.
Excellent. Thanks, Bill. And Laura, if you'd care to address the topic of analysis period, we've got just a couple minutes.
Bill said it pretty well. It really depends on. It will change from asset class to asset class, and it really kind of have to have an idea of what your investment needs over a long period of time are before you start to make it a little shorter. We tend to keep ourselves on a couple of different cycles just based on the way that we have to report to regulatory agencies. We do a 12-year capital plan, we have to do a 25-year TIP, and we use our asset management to work into the long-range plan with our MPO.
Excellent.
And it depends. Yeah.
And so I think that's going to be the last question we're able to take. We're out of time on the Q&A. And so wrapping up, the next webinar is going to be held February 8, 2017, 2 p.m. Eastern Time, and it's going to address TAM communications. I hope you'll all be able to join us. We'll have webinars scheduled out for another year or so. Please send ideas for webinars you'd like to see. Just want to wrap up by saying thank you to all of our presenters today and to all of you for joining us. And just a final reminder, for more information, you can visit tam-portal.com. Thanks, everybody.